Hello guys, myself Swapnil Sir and I'm welcoming to you all on our lecture series based on the SPI exam. Already we have started lecture series based on the SPI topics. If you are interested to see this video, do check in my playlist. So in my today's video, I'm going to explain to you all one of the very much topic from the mathematics, which is a probability, and after that at the end we go for solving some sort of examples. Okay, so without further ado, let's get dive into our today's lecture. First of all, we are going to see here some of the basic concept related to the probability, and at the end we go for solving some questions. Okay, now let's get started our today's lecture. Now this lecture which completely based on the probability chapter. Okay, yes, and this one is our 12th lecture. Already we have uploaded plenty of the lecture other than this. So if you are interested to see this video, do check in my playlist. Okay, now let's get started our today's lecture. Okay, first of all, I'm going to explain to you all probability and some sort of the likely outcomes. Okay, for some random events. Okay, so I will explain all this terminology with respect to some of the examples. Okay, now what actually meaning of a probability here? Probability, it means that we have to find out the likely outcome or a probable outcome for some sort of certain event. Okay, with we use some terminology like a sample space, like a random event, favorable event. All these concepts we are going to learn here first. We're going to understand it first here, then at the end we go for solving some of the example based on the SPI exam. Okay, so in our SPI exam, probability chapter carries near about 14 to 16 question. Okay, near about 14 to 16 question, 14 to 16 question that probability chapter carries here. Okay, so you have to be very much careful about these questions. Okay, because all these questions are very much important. If you're going to observe the question papers, you can see the question based on tossing of a coin. You will get some random experiment like a tossing of a coin, a tossing of a dice, like the operation on a deck set, or you will get some random events. Okay, so based on this 14 to 16 question, you will get the tossing of coin, okay. After that you will get the tossing of a dice. Okay, tossing of a dice. After that you will get here operation, some random events on the set of a deck. Okay, deck set. Okay, so you will get these three random events. Okay, on our sample space. That means question based on these three topics are mostly occur in your question paper. Okay, so we do have 14 to 16 question possibility in our probability chapter. Within that 14 to 60 question all are based in this main part. Okay, so for that you have to understand what actually meaning of a tossing of a coin, what are the possible outcomes that we can define here using the tossing of a coin. After that, tossing of a dice and a deck set. Okay, I will explain just short introduction about all of these concepts. Then we go for the definition of a probability. Okay, now here we can see the tossing of a coin. Now consider that any coin, first of all consider a single coin. Okay, we consider here first single coin. First we consider here a single coin. Okay, what actually happen if you toss a single coin? Okay, if we toss a single coin, we know that the probable outcome when we toss a single coin, whether it is a head or it is a tail. Okay, we have two probable outcome here, whether it is head or tail. Okay, when we toss a single coin, what happen if we combine two coin together? Okay, two coin means, let's consider two different coin. Different coin means both are having head and tail, both faces same here. Okay, two coins. Now if we consider the two coin at the same time, and when we toss two coin at the same time, the favorable outcome it gives us, whether it goes for both coin gives us head. Okay, that means the outcome it comes in the form of order pair. Okay, orders. Okay, now first outcome we do have here, both are the head. Second outcome we can say that both are the tail. Okay, next outcome we can say head tail, next tail head. Okay, After that, we have tail, head, tail, head. Okay, these are the 4 outcomes. Okay, when we toss 2 coins together. Okay, that means 2 raised to n outcomes are coming here. When we toss 2 coins, we get these are the 4 outcomes. Okay, and outcomes in the form of order pair, as we have 2 coins together. Okay, now you can consider, or you can take a random coin in your hand, toss both of the coin at the same time and figure it out how many possible outcome we can get it from there. Okay, yes, after tossing of a 2 coin, we can toss 3 coin too, but we are not going for the further part, as I found most of the question based on the tossing of a single coin, tossing of a 2 coin, or tossing of a 3 coin. Okay, so if a tossing of a 3 coins are there, okay, that means we'll get the 3 outcome at a time. Okay, 3 outcome at a time, that means 3 coins. If we have these 3 coins, okay, if we toss 3 coin at the same times, whether we get the all our head, okay, for the 3 coin, all our head, all our tail, head, tail, head, tail, head, 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 tail, 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 head, all these type of the outcomes you will get it there. The total number of 9 outcomes are there. 3 raised to n, okay, n raised to 2, that means 3 raised to 2, which is the total number of 9 outcomes we can get it from the tossing of a 3 coin here. Okay, yes. Now what about for tossing of a dice? Let me explain tossing of a dice. Okay, tossing of a dice. Okay, what happen if we toss dice at a time? Okay, single dice at a time, as we are already familiar with the dice concept of the dice. Okay, dice, it is having like a cubical shape of, okay, I know that you all are already have seen the cubical shape. Okay, dice, it look like cubical shape, and we know that cube are having total number of 6 sides. Okay, 6 sides means every side which contain 1 dot. Okay, every side which contain 1 dot. If you go for the second side, you will get the 2 dot, third side contain 3 dot, next side 4, after that 5 dot, and total number of 6 dots here. Okay, tossing of a dice gives us, first side gives us 1 dot, second side gives us 2 dot, third side 3 dots, fourth side 4 dot, fifth side 5 dot, and last 6th side we have total number of 6 dot. Okay, as we have total number of surfaces available in our dice, which is a 6. Okay, that means we get the 6 possible outcome when we toss a single die. Okay, when we toss a single die. Okay, when we toss a single die, we get the total number of 6 outcome here. Okay, yes. When we take 2 dice together, we get the outcomes in the form of order pair. Okay, when we get the 2 dice, okay, together, we get the outcome in the form of order pair, and we have possible chances here, total number of 6 chances for single dice. When we go for the 2 dice, that means 6 raised to 2, total number of outcomes we have here 36 outcome. Okay, it gives us 6 outcomes when we toss 2 dice. Okay, when we toss 2 dice, we can write their outcomes. Okay, and always remember that when we have 2 dice, we have to write their outcome in the form of order pair. Okay, in the form of order pair. Now we can see first dice can give number 1. Okay, 1 dot. Second dice also can give number single dot. Okay, first dice can give 1 dot. Second dice can give us a 2 dot. Next, first dice can give us a 1 dot. Second dice, it can give us a 3 dot. Okay, 1 4, 1 5. Okay, 1 comma 5 and 1 comma 6. Okay, these are the total number of 6 outcome when we consider first dice which contain 1 element. Okay, 1 dot. Okay, now what happen if we take as a second dice as the number 2? Okay, so we write a 2 1, 2 2, 2 3, 2 4, 2 5 and 2 6. Okay, okay, from 2 1 to 2 6 we have next possible outcome. Similarly, we can write 3 1 3 2, 4 1 4 2, 5 1 5 2, up to at the end we write a 6 6. Okay, it starts from the 6 1 and 8 it the 6 6. Okay, these are the total possible outcome when we toss two dice together, okay, when we toss two dice together, we get these possible outcomes here, okay. So don't have to go for the 3 dice because it will be a little bit lengthy, okay. Don't have to go for this one. I hope you will have understood that tossing of a single dice and tossing of a two dice at a time, okay. These are the possible outcomes here when we toss single or two dice, okay. Now left part here we have that when we consider the set of a deck, okay, set of a deck. Let me explain the set of a deck. Set of a deck, okay. Now consider that already we all have seen already deck set, okay, or already might use, some of you all are played that deck set too, okay. Okay, so deck set means we have total number of 52 cards, okay. As the part of a probability, we have to consider them here for our calculations, okay. Don't consider or don't take it personally. This is the part just of a calculation in the form of our probabilities and their favorable outcomes, okay. Now let me explain with the deck, set of a deck, okay. We know that the card it look like this way, okay. Deck card, single card, it is look like this way. Some cards contain number 1, 2, 3, not a 1, like a ace, 2, 3, 4, like a jack, king, queen, okay. All these cards are there, okay. So we have total number of like this 52 cards, okay, like this 52 cards. I know that you all already familiar with these 52 cards, okay. These are the total number of 52 cards. We already know that this deck set contain 52 cards, but under 52 cards there is also division, okay. Under 52 card there is also division, and that division contain 13 card of each set, okay. 13 card of each set. Now we can see that here 13 card, here we get the 13 card, again here we get the 13 card, and last we have here 13 cards, okay. 13 4s are 52. That means 52 cards which divided here into the 4 equal part, okay, which is a 13, 13, 13 and 13, okay. Yes. Now to identify these 13 cards, okay, they do have some symbols, okay, like a heart, diamond, spade and club, okay. Heart, diamond, spade and club. Let me write the identifying symbol. Heart, diamond, spade and club, okay. Heart, diamond, spade and club, these are the symbol there that we can identify. These are the 4 different cards, okay. Their colors are also different that you can identify easily, okay. After that, every set of a 13 card, every set of a 13 cards which contain some specific numbers, okay, and that numbers are, first it goes for ace, okay, that means one number is generally denoted as a ace. Second we have number 2, 3 up to we have number 9, okay. After that jack, that we denoted it as the capital J, okay. King, capital K, and queen, okay. We have here capital Q, okay. Jack, king and queen, these are the complete division of a 13 cards here, okay. It is not only for the heart, it is similarly for diamond, spade and club, okay. So similar division it goes here, similar division it goes here, and similar division it goes here, okay. This is the complete division of 52 cards, okay. I'm expecting that you all have understood the deck set and their division, okay. So we can divide heart, diamond, spade and club, which is the complete division of a 52 cards, okay. And in your SPI question paper, at least you will get the 4 to 5 question based on this deck set, okay. So try to understand what are the actually sets there, okay. Try to figure it out, what are the possible outcomes, what are the major example that you learn, okay. Just find it out the solution for them. You can, it will be a good practice for you all, okay. This one is for the deck. Already I explained here about the coin, what happen if you toss 2 coin. Next I explain here next the concept, what happen if we toss a dice, okay. Under dice we toss single die, 2 dice at a time. about that set of a deck, I consider here a deck which is having 52 cards, okay, that can contain 52 cards, and it contain 13 4 sets, okay. Understand this division here, okay. So in your exam you will get the 52 card deck set, and you have to find out some probable event or a random event based on this, okay. Yes, now let me explain some certain event that we needed here, okay. Yes, what actually mean by favorable event or random event or sample space, okay. Actually sample space means the total number of event we have present here in our example, okay. Total number of event, so we have total number of 52 cards. We do have total number of 52 cards. That means our total sample space here as a total 52 cards, okay. Now within that I have to define some random event or favorable event, okay. So random event, it define as we have to select here all jack which present here in our 52 cards, okay. All jack which are present here in our 52 cards, then we consider it as the random event or favorable event, okay. And we know that each set which contain one number of a jack, here it is also single jack, here it is also single, here and here, okay. Total number of a jack we have here 4, okay. Total number of jack we have present here 4 jack, okay. Yes. Yes, total number of jack we have 4 jack present here, okay. So this one is our favorable event or random event, okay. Out of 52 cards means we have total number of a sample space which is a 52 cards here, okay. Yes, so this one is actual definition for random event, favorable event, and after that sample space, okay. All this based on those different set of a deck set. After that we have next coin toss. After that we have tossing of a dice, okay. But other than these operations, other than these sample spaces, we do have some another too. Like consider that we have 30 boys and girls present in our class. That is the also we consider here as the event for probability, okay. That means total number of 30 boys in our class, which is a total number of a sample space. Within these boys we have to select only the girls, okay. Consider that 20 girls are there, so our random event which says that we have to select 20 girls, which is the random or favorable event in our sample space, okay. So that's it here about the basic concept that we want here in our probability. Let me explain some of the formula that which is important for our further part of example, okay. Yes, okay. Probability. So based on this basic event, we go for the basic formulas. We go for some multiple choice question, okay. These are the basic question, but most of you all are confused about it, okay. So in your SPI question, not all the questions are coming difficult, okay. There are near about 40 to 50% question, 40 to 50% question they are easy, okay, that you can attempt them easily. It's not that difficult, but what you need to know, you need to understand some basic, all the basic related to the probability, okay. Now let me explain what actually the probability here for some random event or some favorable events, okay. Yes, now let me explain about the probability. Now consider that I do have one random event, okay, and I want the probability for that random event. We write the probability of any random event. Let me write probability of any random event. Probability of any random event, we write probability of any random event, we write number of favorable outcomes, okay. Number of favorable outcome that we are going to consider over a sample space, okay. So we write number of favorable outcome divided by total number of event, total number of events in sample space. total number of favorable outcome divided by total number of events in our sample space. Okay, that is the actual definition for probability of a random event. Okay, you all have to understand this formula better. Okay, once you can understand it, understand this formula, you can solve the example easily. Okay, just understand the meaning. Probability of any event, we define it as the number of favorable outcome divided by total number of events in our sample space. Okay, yes. Yes, now next part, consider that we have probability of any event as a E. Okay, event, consider event as a E. Okay, consider event as a E. Okay, event as a E. Now probability of event E. Okay, probability of event E, which is denoted as P of E. Okay, probability of any event E, we denote it as the P of E. Okay. And always remember that probability of any event which starts from 0 and end till 1. Okay, that means the value for any probability which lies between 0 and 1 here. Okay, so probability of any event which start from 0 and end it to the 1. Okay, that means the probability of any event lies between 0 and 1. Always remember that if you get the answer in your question exam, that probability of any event which bigger than 1, then always make sure that your answer is wrong. Okay, when you can confirm your answer when you can confirm your answer is wrong or right, okay, you have to confirm first of all whether that probability it is lies between this event or not. Okay, between 0 and 1 it is lies there or not. Okay, then we say that the probability of event we have here between 0 and 1. Okay, now when we have probability of any event between 0 and 1, so at the lowest value 0, at the lowest value 0, that means probability of event which is a 0, we consider it as the failure of the probability or unsuccessful probability. Okay, failure. Okay, failure of probability. Okay, failure of probability. Okay, and when we have probability which gives us the value 1, then we write a successful probability. Okay, successful probability. That means when we have probability is a 1 which is a sure event. Okay, remember the meaning. When the probability of any event is a 1, then we write it as the sure event. Okay, okay, probability of any event is a 1, then we write a sure event. Okay, okay, probability of any event is a 1, then it is a sure event. Probability of any event, if you get it 0, then we write unsure. Okay, that we cannot sure about that was a certain value, then we write the probability of that event which is unsure. Okay, so these are the actually major result we want here in our probability. Okay, okay, and one more result, that if you have event A, event B, event C, event D, these are the disjoint event which present in our same sample space. Okay, if we have n number of different probability which present in our sample space and all these probabilities are different, then we consider different means disjoint. Okay, and if the probability of events are disjoint, that means their intersection is phi. Okay, intersection of two elements are probabilities are phi, then we consider it as the disjoint event. Okay, yes, and when we have two events, if these are the disjoint, then we write, okay, probability of any event. Okay, probability of any event or probability of n number of events which define in our same sample space. Okay, like we have single sample space. Let me write. We have single sample space. Okay, based on that sample space we have probability A, event A, which gives us the probability of A, okay, on same sample space. Okay, based on the sample space A we have event B, which gives us the probability B based on event C, based on our sample space event C, which gives us the probability C. Okay. So now see that probability of A plus probability of B plus probability of C in entire our sample space gives us the value 1. Okay. So if we add all these probabilities, we get the value always 1. Always remember these formulas. Okay. These are going to very much important in your upcoming SPI exam. Okay. So let's get start the next part of our today's lecture, which is mostly we are going to focus on plenty of the examples. Okay, examples are needed. Other than examples, you cannot do anything in mathematics. Okay, most of the examples we needed here for finding the for practicing the these topics. Okay, practicing the topics are very much important. So let's get dive into our today's main part of the lecture, which is the examples. I know that you all are excited to see these ones. So let's get dive into our today's example session. Okay, yes. Okay, now first example I taken here. These are some basic examples. Okay, these are some basic examples and basic property that you need to understand. Okay, because in your SPI you will get the similar question, but in most of the case, what students they are doing like they're just preparing higher concept and forgetting basic concept, and questions are coming only on the basic concept. Okay, so always make sure that your basic concept has to be a proper, understand it, what are the concepts there, and then proceed for the next higher difficulty. Okay, yes. Now here in our first example, probability of event E and probability of event not E. Okay, probability of event E and probability of event not E. Let me write. E plus not E. Okay, that means actually the probability of a not E means the complement of event E. Okay, if we have event E which is here, the complement of event E which is the outside part of that event E. Okay, yes, the complement of event E which is generally denoted not E. Okay, in the case of a probability, but actually meaning of a not E it consider as the complement of event E. And always remember that probability of event E plus probability of event not E, which gives us always value 1. Okay, always remember E plus not E, which gives us the value 1. Okay, so which gives us option, our first option correct, because we know that probability of a n number of a probability which define in our same sample space, n number of probability which define in our same sample space gives us the value 1. That's it only. Okay, so it gives us the required answer 1, which is our option first correct here. Okay, yes, I hope you all have understood this solution for this example. Okay, let's move for the next example. In our next example, probability of an event that cannot happen. Okay, yes, already I explained that question in my starting of the question, starting of the lecture. Okay, probability of that event cannot happen, that means which is an unsure event. Okay, probability of event that cannot happen, let me write. Probability of event that cannot happen, can't happen, probability of event that can't happen, we write it as the unsure event. We write it as the unsure event. And we know that whenever we cannot decide or probability that not happen or it is an unsure event, we write the probability of that event, which is a 0, probability of that event which is a 0 here. Okay, such a event called it as the impossible event. Okay, such a event called it as the impossible event. That means it is not possible. Okay, so if we have to find out the probability for some certain event, it actually it has to have some sort of a value which other than 0. Okay, and if it is a value coming 0, then we say that impossible event or unsure event. Okay, unsure event. So option number C, which is correct here. I'm expecting that you all have understood this solution. Let's move for the next question. Yes. In our next question, we have given a probability of an event that is a certain to happen. Okay, dash dash such an event is called as a sure or certain event. Okay, similar already I explained. Okay, sure event or a certain event. Okay. Sure event or sure event or certain event, or the probability of a event certain. Okay, that means we know that probability, it gives us some fixed value, or it is going to happen some perfect time. Okay, then we consider it as the sure event or certain event. Okay, and we know that if the probability of any event it is the sure or possibly fixed, then we write it's the probability of any event or probability of event, probability of that event which is the 1. Okay, sure event or certain event, we write it's the probability is 1. Okay, now which is given in our option number D. I hope you all have understood this solution of the example. It is not that difficult, just based on the simple definition, and definitely you will get the similar type of the question. Okay, don't forget to prepare this one. Why I have taken this easy question here in my today's lecture? It is the intention behind that you all have to prepare all this concept. Okay, yes, in my previous lecture I explained little higher level example. You can see these examples, practice similar type of the example. Okay, I hope you all have understood this solution. Now let's move for the next question. Okay, yes, in our next question we have given sum of the probabilities of elementary events in our experiment. Okay, sum of the probabilities. Okay, the probabilities, let me write sum of the probabilities of all elementary event. Okay, of sum of the probabilities of all elementary event. I know that we know that you already explained that concept too. Okay, if we have n number of probabilities which define on a same sample space, all are disjoint, we know that their sum always gives us the value. And same question we have here, sum of the probabilities of all elementary events in our experiment. Okay, that experiment is based on same sample space. Okay, which gives us the value always 1. Okay, always 1. Okay, which gives us the value always 1. Okay, that is our correct answer. Okay, I hope you all have understood this solution. Nothing it is difficult here. Okay, so let's move for the next question. Okay, based on the same concept. Okay, probability of a event is greater than or equal to, okay, and less than or and equal to. Okay, already I define here probability of any event, okay, which is greater than or equal to or less than or equal to. Okay, yes, which is the greater than less than equal to, which is a 0, and greater than equal to, which is 1. Okay, now see that we have which is a bigger than 0, always of the any probability of event which is a bigger than 0 and smaller than 1. So which gives us value here 0 and which gives us 1. Okay, so which gives us our option number first A, it is true here. Okay, let's move for the next question. Yes, probability of a getting number less than 3 in a throw of a dice. Okay, now see that this is the little different question. Okay, you will get the similar type of the questions in your question paper. Okay, just need to understand what actually we have given in our question. Okay, Yes, in our question it says that probability of a getting number less than 3 in a single throw of a dice. Okay, so we have single dice. Okay, first of all, understand the sample space. Single dice. Okay, single dice. We have a single dice and we have to throw that a single dice. Okay, when we throw single dice, we know that it is having total number of surface 6 surfaces. Okay, yes, area, top surface, bottom surface, front surface, back surface, and left right surface. Okay, total number of, we have 6 surfaces here. Okay, we start from 1, 2, 3, 4, 5, 6. Total, we have total number of 6 surfaces which present in our dice. Okay, yes, total number of 6 surfaces. That means total number of a sample space, total number of sample space, total number of a sample space which we have present here in our given event. Okay, which is a 6. Okay, number of element in our sample space which is a 6. Okay, and we have to find out the probability of a getting number less than 3. Probability of a getting number less than 3, that means which is a strictly less. We don't have to consider, or we don't have to include number 3. We have to consider the number which less than 3. That means number 1, number 2. Only the 2 possible outcomes here. Okay, okay, event what we have here, number less than 3. What we have, event it is here as the number less than 3. Okay, that means consider the event E, consider this one is the event E, the number of event element in a E. Okay, we want the number of element in E. Okay, so first of all write down the element which are the possible in element E, which is 1 and 2. We cannot consider 2 as the part of our favorable event because we want the less than 3. That means 3 is not there. Okay, if it is there less than or equal to 3, then you can include. Okay, yes, so we have number element in a event E which is a 1 and 2. Number of element event in a E which is the number of element which is a 2 here. Okay, now we want the probability that getting a number which less than a 3. Okay, the probability of a number which getting number of less than 3, which is a number probability of event E, which is equal to number of favorable outcomes, that we denote it as the number of element in a E divided by total number of element in a sample space. We write number of element in a sample space here. Okay, what is the number of event E? Favorable outcome we have here 2. Number of event element in a sample space we have here 6. So 2 by 6 we write 1 by 3. Okay, which given in our option number C here. Now see that how easy type of the questions are here. You need to have a basic concept perfect here. Okay, try to understand these concepts. Okay, not it is difficult. Okay, I hope you all have understood this solution. Let's move for the next question. Okay, in our next question we have given probability of event E which is a 0.05. Okay, let me write probability of event E which is given 0.05. Okay, so probability of event we have given here 0.05. Okay, and our claim it is here we want the probability of event not E. Okay, what we have claim? Okay, we want the probability. Okay, we want the probability. Let me write of event not E. Okay, that means probability of event not E means probability of event E complement. Okay, we define probability of event E complement as the probability of event not E. Okay, yes, now let's let me write one formula that we already learned earlier in our lecture, that it says that probability of event E plus probability of event not E gives us always value 1, because these events define on same sample space. All these events define on the same sample space. Then we write probability of event E and probability of not event not E, which gives us a value 1. Okay, Yes. So what is the probability of event E and probability of event not E? Already we have given probability of event E, which is a 0.05. Okay. Probability of event E, which is given in our question, which is a 0.05. Okay. I substituted that value here, and we want the probability of event not E. Okay. We want the probability of event not E. Okay, which gives us the value 1. Okay, take it that value to the other side, so we write probability of event not E. Okay, not E, which is equal to 1 minus 0.05. What actually I have done here, that is 0.05 I have taken to the other side. Okay, 0.05 I have taken to the other side, it gives us the negative value. Okay, that means that positive it gives us the negative, and then 1 minus 0.05. Okay, so option it is not mentioned here. Okay, that option we have to write here. So that means 1.00 minus, okay, 1.00 minus 0.05. Okay, 0.95. Okay, 0.095 you write this one. Okay, this is the our right answer in our example. Now see that it is a very easy example. You will get the similar example in your question. Okay, probability of event E plus probability of event not E, which is equal to 1. I'm expecting that you all have understood this solution. Okay, let's move for the next solution question. Okay, this one is the last question for our today's lecture. Yes, now in our question we have given a bag contain 3 red balls. Okay, we have a bag. Okay, we have a bag which contain 3 red balls. Okay, okay, we have a bag which contain 3 red balls and 5 black balls. Okay, a bag contain 3 red plus 5 black balls. Black balls. Okay, bag contain 3 red and 5 black balls. Okay, this is our given condition we have here. And next, a ball is drawn at a random from the bag. Okay, so we have bag, we have to draw one ball from the bag. Okay, randomly, any that bag ball can be anyone, like a red or maybe black. Okay, total number of balls we have in our bag, which is a 5 plus 3. Total number of ball we have here, total number of 8 balls we have present in our bag. Okay, so total number of balls means we have sample space. Okay, total number of balls we have, which is a sample space. Okay, total number of balls we have sample space, and number of element in a sample space we have here, total number of ball, which is entire ball which is present in our bag. Okay, 3 red and 5 black ball. Okay, that means total number of element in our sample space we have 8. Okay, yes, a ball is drawn from random of randomly bag. Okay, we have to draw one ball from the bag randomly, it can come anyone. Okay, yes, what is the probability that ball drawn red or not red? Okay, now first we want the probability that ball is red. Okay, ball is red, that means when we have red ball, then we have to find out the probability. Now first let me write what is the probability for red ball. Okay, when ball is a red, I'm going to write with a red pen. Okay, because ball it is a red. Okay, so we cannot write by black. Okay, as we don't have, yes, it is only for red. Okay, yes, when ball is a red, then what is the probability? Okay, what is the probability? Now see that probability of getting ball red means number of a favorable event divided by number of sample space. Okay, number of favorable event divided by number of sample space, which is the total number of red ball in our bags. Okay, yes, 3 red ball and 5 black balls. Okay, a ball which drawn from the bag. Okay, and what is the probability that ball is red? That means the total number of element in a sample space is total number of 8 element. Okay, and we have favorable event, that is the ball red. Okay, so favorable event what gives us here? What is the favorable event? Number of red balls, okay? Number of red balls, okay? Number of element in R, which is 3 here, okay? And we have the probability for finding the favorable event in our bag, okay? Which is the red one, okay? So we write a number of element. So probability of element in a for red ball, which is the number of element in a bag red divided by number of element in our sample space. So how many number of element we have here? 3, and number of element in a sample space we have 8, okay? That means the probability of getting only the red ball, we write 3 by 8, okay? So 3 by 8, which we have in our option number C, but only the part which left here, okay? So the part which says that, okay, the part which says that what happen if the ball they are not red, okay? If the ball they are not red, what it is the probability, okay? So we know that probability of a sure plus unsure event, which gives us the 1, okay? That means probability of a event for red plus probability of event for not red, which is equal to 1. Always remember that the addition for the two probabilities, if it is the red and if it is the not red, okay, always gives us the value 1, okay? Make sure this concept, okay? Yes. Okay, so what we have, probability of event for red, which is a 3 by 8. We want the value for probability of event not red, okay? Probability of event not red, which is equal to 1, okay? So what we want? We want the value when balls are not red in our bag, okay? So we write probability of event not red, which is equal to 1 minus 3 by 8, okay? That positive 3 by 8 I taken to the other side, it gives us the negative value, okay? So 1 minus 3 by 8 means 8 ones are 8 minus 3, okay? 8 minus 3, which is a 5 by 8 here, okay? When we have balls completely red, that to drawn from our bag, okay? So we consider it as the probability of our red ball, okay? And when we have probability of that ball which is not red, we write it as the 5 by 8, okay? Which is the not red. So our option C, which gives us the correct answer, okay? So I'm expecting that you all have understood this entire solution, okay? So that's it for our today's lecture, okay? In our today's lecture, we learn here probability and some concept related to the probability. I'm expecting that you all have understood that we begin our lecture with the concept from probability and some terminology related to the probability, okay? So probability of any event, we know that which lies between 0 and 1, but that probability having some terminology like a sample space, like a random event, like a favorable event. All these terminologies are important here in our probability chapter. I'm expecting that you all have understood everything in my today's lecture. If you like this lecture, let me know in my comment section. Even after, if you do have anything doubt, difficulty, do let me know, okay? So I hope you all have understood everything. So thank you everyone. Thank you for my today's lecture.